Hi people, these notes are on solving rational equations, and the first part of our video is asking us to determine common denominators for each of the pairs of fractions below. So in our first example right here, our common denominator, we're going back to elementary school math. If I have a denominator of 5, a denominator of 10, the least common multiple of 5 and 10 is going to be 10. Okay, the reason being is that 5 is just 5. It is a prime number. And then 10 is 5 times 2. And they have the 5 in common, so our LCM will have a 5 in it. And then LCMs are like super inclusive, so they want to make sure that all the factors are included. So they're also going to include the 2, so our LCM is 10. Taking a look at this next one right here, 3x is just 3 times x, and then 4x squared is 4 times x times x. So right here, we can say that our LCM is going to have a 12 in it because we're going to include the factor of 3, the factor of 4, which is technically 2 times 2. There's also an x in common, but then there's another x as a factor that needs to be included because, again, we're inclusive. We're going to include everyone. So 12x squared is our least common multiple. And what we're trying to do here is we're trying to make both of these into 12x squared. And we can change a 3x into 12x squared by multiplying by 4x. And we can change a 4x squared into 12x squared by multiplying by 3. And then we can do the same thing with the numerator here as well. Okay? In this next example, our denominator of that 4, the second 4 is 1. So right here, our LCM is going to be this factor, which is 3x minus 5. And because this denominator has a factor of 1, there's technically a 1 in front, but I don't really need to put that. So we can just say our LCM here is just plain and simply 3x minus 5. Okay? All right, in this next one, in order to find my LCM, I have to find out what my factors are first. So don't forget that we have to factor, okay? So right here, this denominator right here is x plus 1 times x minus 1. And then this denominator here is just plain old x plus 1. So then I'm going to look and see for my LCM, I know that there's an x plus 1 in both of these denominators, but then we also have this x minus 1 right here. We have to be inclusive, so our LCM is x plus 1 times x minus 1, okay? In the next example, I'm going to factor this again. So right here, this denominator is going to be x plus 4 times x minus 1. And then here, this denominator is going to be 1 minus x times 1 plus x. The 1 goes first because we have a 1 here first. So now when I do this right here, I have to take a look at this really carefully, and I can see that these right here are negations of each other. Go ahead, you can stir it. You can stir it. Okay. So I can say here this x minus 1 is the same thing as the negation of 1 minus x, because when I distribute this through, I get negative 1, and then I get positive x, which is the same thing as this right here. So because of that, I'm going to rewrite this right here as a negative x minus 1, and then 1 plus x right here. And then I'm going to take this negative and put it on top in my numerator right here. So that negative that we have on the outside right here doesn't have an effect on my LCM, but it will have an effect on the next step of stuff that we're going to be doing. So here, our LCM is going to have a factor of x plus 4. Then we're going to have an x minus 1. And then we're going to have a 1 plus x or an x plus 1. So all of these are factors of my LCM. And then lastly, over here, in this denominator, I cannot factor it any further. So it's just x minus 2. In this denominator, I can't factor that any further. So my LCM is going to have a factor of x minus 2, and then another factor of x squared plus 6, and that's it. That's all I can do right here. And I found my least common multiple. This is all review from grade 11 math, but this is good review to help us out when we start to solve these rational. Okay, so let's apply this to this question right here. It says determine the point of intersection of these two functions right here. So there are two methods that we can actually do to solve this question. In this video, I'm going to talk about one method, okay? And there's a very specific reason why I'm going to talk about this method. You might be like, why are we doing it that way? It's a very strange way to do it, but you'll understand when we get into our inequalities. But I do want to show you how to do it right now so you have an idea of what's going on. And then we'll also discuss the other method through our exploration of this content in class. So because I want to know where these two are going to intersect, I would set them equal to each other. So I'm going to say 2 over x squared minus 1 is going to equal x over x plus 1. Now, this is where you're going to be like, what? Why are we doing this? But I promise you it will make sense when we get into our inequalities. So I'm actually going to get everything on one side and set it equal to 0. So what ends up happening is I end up getting, I still have 2 over x squared minus 1 right here. I just bring that down. But then I'm just going to subtract this x over x plus 1 over here. So I'm going to say minus x over x plus 1. Then I'm going to factor to find my LCM. So we know that this right here ends up being 2 over x plus 1 times x minus 1. And then I have minus x over x plus 1, and then I'm going to say equals 0. Now, our LCM, our least common multiple, is going to be x plus 1 times x minus 1. And in saying that, we also need to identify what our restrictions are. So x can't equal -1 or +1. If you want, we can say x can equal plus or minus 1 like this. Now that I know what my common denominator is, I'm going to make a single fraction out of this whole entire left side right here. So in order to do that right here, I'm going to say that this is 2 over x plus 1 times x minus 1. And then I'm going to copy down this minus x over x plus 1. But in order to get this LCM that we have right here, I have the x plus 1 in my denominator, but I'm missing this x minus 1. So I'm going to extend this and say that I'm missing an x minus 1. But whatever I do in the denominator, I also have to do in the numerator. And that will all equal 0. Okay, so now that I've done that, I'm actually going to put this all together into a single fraction now that our denominators are common. So now, because they both have the same common denominator, I can put them together into the same fraction. So I've got x plus 1 and x minus 1 in the denominator. I just copy down this 2. I copy down the minus sign, and then I've got x times this x minus 1 right here. Bring this up here so I have more space to get some of this work done. So right here, I'm going to have 2, and then I distribute the negative x through, so I get minus x squared plus x all over x plus 1 times x minus 1, and that should equal 0. So then I'm going to do two things in this next step. I'm going to put this in descending order, but I'm also going to factor out the negative because my leading coefficient is negative here. So I factor out the negative. This negative x squared becomes a positive x squared. This positive x becomes a negative x, and then this 2 becomes a negative 2, and that's all over x plus 1 times x minus 1. I'm going to do a little bit more factoring in the numerator. So I would get x minus 2 and x plus 1. And then in the denominator, I have x plus 1 times x minus 1. But don't forget that when we're solving equations, just like when we were solving for x-intercepts, we only set the numerator equal to 0. We do not set the denominator equal to 0, because if we set the denominator equal to 0, then that would tell us where our restrictions are. So that means that x either equals, I don't really care about this negative because there's no variable there. So either x equals 2 or x equals -1. But we figured out here that x can't be positive or negative 1. So that means that this right here would be an extraneous solution. Also, if you see here, these would reduce, and remember when we were learning about how to graph, we would know that that means that there would be a hole at negative 1 and not an actual solution. So right here, this is considered an extraneous solution, and it's extraneous because it is a solution that I get when I do the work, but when I plug it back into the original equation right here, it doesn't work. Okay, so that means x equals 2 is the only possible x value. I'm almost done, but the question says to find the point of intersection. So I need to find the point of intersection of where these two graphs would intersect with each other. Well, I know the x value is going to be 2 because that's what we figured out right here. But to find the corresponding y value, I either have to do f of 2 or g of 2. I'm going to do both so you can see how you get the same answer. So when I do f of 2, it's going to be 2 over, I'm just going to do this quickly, 2 squared is 4. 4 minus 1 is 3, so I get 2/3. But then when I do g of 2, it's 2 over 2 plus 1, so I get 2 over 3, which is also 2/3. So that means that my point of intersection would be 2, 2/3. And that's how you solve a rational equation.